Hi, this presentation is actually trying to answer a long asked question with no specific answer. So today what I'm trying to do is trying to answer this question here, why quantum, as the chosen method for our universe. So this question was asked once quantum was it's the meaning of what we observed in quantum experiments was understood. So those are the people who understood it most. And Einstein, when he knew about what the quantum physics predicts or try to point out something, he came out with a statement saying that God does not play with dice. Obviously, because what he understood from the observation he noticed in quantum experiments is that it is as if God is playing dice, or in other words, the creator of that universe. So Bohr replied to him saying, "Stop telling God what to do." I'm here. What I'm doing tonight is suggesting a explanation, one of the explanations that what God may be doing. Next slide, please. So, what is quantum physics? It's basically the physics of the micro things, the things that we don't see with our eyes. So, it is the science that describes the nature of atomic and subatomic particles, like electrons, photons, small molecules, even, yani multiple atoms together, not just one atom, multiple atoms together, like carbon 60, which behaves like as if it's an electron or a photon. Quantum physics identified several characteristics of the quantum particles, which are these here, which are the constituents of everything, including ourselves. You are composed of atoms, and atoms have these particles inside them. So this actually describes the physics of everything, not just this world, everything around you, including air, including have atoms, and atoms have these particles in it. So what are we gonna try to explain today, or you should know before entering this presentation, are these three specific observations about quantum physics. The first one is wave-particle duality, that the actual components of the universe is acting in two ways, a wave or a particle. What we understand is everything around us is a particle, but a wave is something else. It's not that physical. And then the idea of superposition, which will be explained in the videos later, or you should have known it already before coming to this presentation. And then the measurement problem, the observer effect on the wave-particle duality. So I know these are big terms, but I'll try I searched the internet and found two videos that might help you understand what I mean by this. Next, please. So this is an experiment that will explain to us what do they mean by wave-particle duality and what it means by superposition. So please start the video and make it screen full. Make it full screen, yeah.
And here we are, the granddaddy of all quantum weirdness, the infamous double-slit experiment. To understand this experiment, we first need to see how particles, or little balls of matter, act. If we randomly shoot a small object, say a marble, at the screen, we see a pattern on the back wall where they went through the slit and hit. Now, if we add a second slit, we would expect to see a second band duplicated to the right. Now, let's look at waves. The waves hit the slit and radiate out, striking the back wall with the most intensity directly in line with the slit. The line of brightness on the back screen shows that intensity. this is similar to the line the marbles make. But when we add the second slit, something different happens. If the top of one wave meets the bottom of another wave, they cancel each other out. So now there is an interference pattern on the back wall. Places where the two tops meet are the highest intensity, the bright lines, and where they cancel, there is nothing. So, when we throw things, that is, matter, through two slits, we get this, two bands of Higgs. And with waves, we get an interference pattern of many bands. Good so far. Now, let's go quantum. An electron is a tiny, tiny bit of matter, like a tiny marble. Let's fire a stream through one slit. It behaves just like the marble, a single band. So, if we shoot these tiny bits through two slits, we should get, like the marble, two bands. What? An interference pattern. We fired electrons, tiny bits of matter through. We get a pattern like waves, not like little marbles. How? How could pieces of matter create an interference pattern like a wave? It doesn't make sense. But physicists are clever. They thought, maybe those little balls are bouncing off each other and creating that pattern. So, they decide to shoot electrons through one at a time. There is no way they can interfere with each other. But after an hour of this, the same interference pattern is seen to emerge. The conclusion is inescapable. The single electron leaves as a particle, becomes a wave of potentials, goes through both slits, and interferes with itself to hit the wall like a particle. But mathematically, it's even stranger. It goes through both slits and it goes through neither. And it goes through just one and it goes through just the other. All of these possibilities are in superposition with each other.
At the
But
same time.
physicists were completely baffled by this. So they decided to peek and see which slit actually goes through. They put a measuring device by one slit to see which one it went through and let it fly. But the quantum world is far more mysterious than they could have imagined. When they observed, the electron went back to behaving like a little marble. It produced a pattern of two bands, not an interference pattern of many. The very act of measuring or observing which slit it went through meant it only went through one, not both. The electron decided to act differently, as though it was aware it was being watched. And it was here that physicists stepped forever into the strange, never world of quantum events. What is matter? Marbles or waves? And waves of what? And what does an observer have to do with any of this? The observer collapsed the wave function simply by observing.
So let's stop this. I guess you are intrigued enough by now to know how weird is quantum, but quantum physics.
And here we are.
Just escape. Escape. So now you are intrigued enough. Obviously, what this experiment showed us, it showed us two things. Go back to the previous slide, please. Showed us that, first of all, what a wave means. The wave means it is all the possible conditions of the particle at the same time. That's what it means by a wave. all possible places where this particle, let's call it instead of place, condition, all possible condition of this electron is happening at the same time. That what means by superposition, that all of the possibility are actually physically exist, and because of that it's acting like a wave. The minute an observer needs some definition, further definition, an observer try to observe that electron, it becomes not a probability of all the position of all the conditions that this becomes in one. So the superposition meaning that the electron is actually behaving like a wave in all the conditions of the electron, to the point that it is interacting with each other because it went through both slits and interacted with each other as a wave. And that's why the interference pattern showed on the screen. The minute an observer, the electron knows that it's being observed, it changes its nature from a probability of all its conditions to one of these conditions, which is a particle, here, at this slit, and start forming two bands, which is a deterministic way. So the first one we can call a probabilistic way, and the second one with two band is a deterministic way. What do I mean by observer? Any observer? That is where the next experiment, if you have in your mind any doubt that the effect of the observing apparatus is what made this happen, that because there is an apparatus in the way of the electron that made the electron behave deterministically, in other words, two bands only, the next experiment erases that. It is no effect of the measuring device itself. It's the fact that somebody will know the result. The knowledge, the fact that somebody may know the result, made it deterministic, made the electron change itself. Who qualifies to be an observer? One entity in this universe, you, the human being. The minute there is a possibility that a human being will observe, it becomes deterministic. That's what made Einstein say, because in this probabilistic form of the universe, before anybody observes, looks like as if God is playing dice. All the probabilities are out there, to the point that it made people interpret this, that there is multiple universes of all the possible outcomes of the current second. So I may step this way, and another version of me may step this way. There is a universe, the same, since all the probabilities are existing, that means there is another universe where the other person stepped this way, that we don't see, and he's just separated at this moment from us, and we can't see it anymore. We only look at the one that we observed the motion this way. But I disagree with that interpretation, but that's what the scientists, when they saw these results, came to conclude. There's another video that tells you that there is no impact of the measuring device. It's nothing because of the measurement device, that it's because of the fact that somebody will know. If you want me to go through it, I'll go through it, but you can trust me for now, for the sake of time, and we'll go to my story that based on these ideas that you just saw right now. So we have a universe that actually is in all states until the human makes his present decision. And then it becomes a reality. The human makes the decision or the intention to measure, and then the universe make it a reality in front of them. The fact of the nature of this reality, or where the point will fall on the screen, on those two bands, is not determined by my observation. No. The point would fall based on what we call random within this band, anywhere within this band. But where? Nobody knows. Where exactly? Nobody knows, or nobody can calculate until I observe. Then I see a path, then the path leads to that point on the screen. Right? But where that path takes the point, I have no control over it. But only effect that I have on the system is I change it from all probabilities to one probability. Okay? So let's go to the next slide. Click. Not click.
And here we are.
Stop this and click next slide.
And here we are, the granddaddy of all quantum weirdness, the infamous double slit experiment.
This is I recommend that if you want to prove to yourself that there's no impact of the measuring device, this experiment called the delayed choice quantum eraser, you can go search it yourself. But I can tell you that it is not the impact of the measurement device. It's the impact of your knowledge, of the probability that you may know it. So, what I'm going to use today is a methodology known to the scientific society as called reverse engineering. So we have a design, which is what we saw from quantum physics. That's a specific design that is working. And we want to understand why. But the question why has to assume intelligence behind the design. So you have to entertain me for a while that there is an intelligent designer for this universe. I know everyone has different beliefs, but for the purpose of this presentation, or to keep going through my assumption, we have to assume that there is an intelligence behind this. This is done for a purpose, in other words. This is not done by random. So if there is an intelligent entity behind this design, what did they want from this design? What may be? Again, I'm guessing here, and I'll let the judgment to you at the end. So the story goes as follows. A programmer invented artificial intelligence code, basic code, that would allow this code to learn and develop itself based on its own self without the interference. You know, you understand what an artificial intelligence is. I put base code, and this code, as time goes, start learning, and accumulation of the learning make him learn more and become more, and so on. So he developed this AI, basic code of the AI. The only thing about this AI, it just enables the AI itself to learn through the learning that he will, and the experience that he will get subjected to. All right? The programmer let multiple instances of this AI to actually start developing itself. So they came out to be distinctively different. Every AI developed in a certain path. He chose his path, right? Now the programmer has this, okay, I have those bunch of AIs. I need to test those AIs to rank them basically, which is the most learnable and intelligent than the other AIs that didn't develop themselves far enough. So he decided to develop a simulation environment to test the learnability of those AIs, how much they can learn and develop themselves, and would they develop themselves in the right way, or they will go wacko with it. So the test is aimed at ranking different AI versions, the one that developed themselves, those bunch, to keep the most learnable out of them and discard the one that went the other way. so he can further use those good ones. The simulation to fulfill the certain requirements of the test to be meaningful. Otherwise, the results of the test are not really meaningful. So there has to be some kind of what we call in the design cycle world, test method validation, making sure that the test method results is actually giving me what I'm looking for, right? So these are the analogies that I'm doing to the design process. So this simulation has to have the following requirements. The environment that I'm going to put the AIs in has to have the following requirements. The AIs has to be, while they're within the simulation, has to be independent from the programmer. Physical influence on the decisions. He wants them to make the decisions independent of him. Their own decisions, not his decisions. Only that means only the learning and the experience should influence their decision. What they learned, how they develop themselves, what they learned and the experience they go through during the simulation is the only influence on that. So I can test their learnability, not my influence, right? As a programmer. With no material proof of the programmer. They will go into simulation, they think that this simulation is everything. There's no programmer, there's nothing, it's them and they're independent. And so the fact that the programmer is present in the simulation will completely destroy the simulation. Because now they are looking at the programmer and they're asking for knowledge. And the only knowledge they will follow is the knowledge of the programmer. No, programmer need to be independent from those AIs. Those AIs need to act on their own. And at the same time, the simulation has to force specific test scenarios for every AI, because every AI is unique from the other. So I need, for this AI, I need to create a specific set of situations where I will test his learnability. I will test, did he learn? Did he develop himself good enough to learn or not? So there's two things. He has to choose within the test freely, but I have to design the test so I can get the information that I want. So that's two contradictory things. How can I create an environment where I don't know your choices while I have to keep the storyline going? Imagine a simulation or a game like Sims. I don't know if you ever played Sims. It's a simulation world where people interact with each other, but instead of being in physical bodies, they are in the computer with simulated bodies. They put makeup, they go out, they meet each other, but they are real people, but in a simulation. But these people know they are in a simulation, so there's no point of testing because they can act differently. But I need them to believe that they can influence this environment. In other words, when they push this thing, it has to move. It cannot be probably move or not. This world has to seem deterministic to them. So on the macro world where we live, not the micro world, it has to look real. No probabilities. When I push this TV with this force, it will move this. Thus, classical physics. The second one, or the fourth one, the criteria of ultimate success of an AI learnability is to recognize that he or she is just an AI code. That's the ultimate. And by a programmer whose existence is outside of this environment. Yet he created it. But its existence outside of this environment. Questions to you. This is the question that I'm posing to you. And you can develop. I don't want an answer from you. This is a question that I'm posing to you. This is my suggestion. Because the previous, or the quantum physics actually resolves this situation. It waits until you make your own decision, then it adjusts the outcome to meet the storyline. So you're free to make whatever decision in the current moment. And once you make the decision, once you observe, once you decide on the current moment, the next moment in all its probabilities out there for the programmer to choose from, to go to the storyline, no matter what are your individual choices. Would that design that we see in quantum physics can fulfill the requirements in the last page, in the last slide? Question. I'm just posing it. And this is the end of the presentation, but there's some side notes that I want to share with you. The programmer actually followed the development cycle, the known development cycle as we know it now. So the programmer understands, because he designed the simulation and designed the basic code, so he understands the specifics of his or her design of how AI is developing to become, and can make predictions about the population using the normal statistical inferences that we do. We take a sample, we test it. This sample make conclusions about the whole population. So he uses still this statistical things. Yet he or she doesn't know every individual AI would behave. He would say, in general, with what I know statistically about this group, they may be prone to doing this. But what each specific one of the AIs would behave, still have to measure it at the current moment where he does behave. The programmer actually verified a prototype of the AI, and I want you to tell me what your conclusion of this. The programmer verified his prototype of the AI to be independent of the programmer. And the prototype actually passed the exam in a prototype simulated environment. Yeah, he made a simulated environment where this first prototype were put in it, and it was tested in a challenging conditions. I'm not going to explain how challenging the conditions were, but that is what happened. And this prototype actually passed. Once it passed the design verification testing of both the AI itself and the simulation around him, he actually started the experiment. Once the AI and the simulation environment proved to be meeting the requirements, the population of the AI start to enter the real simulation environment in a manner that makes it look like a natural part of that simulation. Stop the video. Thank you very much for listening.